Hi friends, this is Abhishek. Today I am discussing about brute force design technique. So let us discuss about what we will learn in this video. In this video we will learn about brute force design technique, selection sort, sequential search, knife string matching algorithm, and advantages of brute force design technique and disadvantages of brute force design technique. So let's first discuss about what is brute force. Brute force is a straightforward design technique that involves examining all possible solutions and selecting the best one among them. Let's look at three algorithms that uses the brute force approach. First one is selection sort and the second one sequential search followed by knife string matching algorithm. So let's discuss about selection sort. Selection sort is a sorting algorithm that repeatedly selects the minimum element from unsorted part of the array and places it at the beginning of the sorted part. It continues this process until the entire array is sorted. Steps for selection sort. In step 1, we must find the minimum element in the unsorted array, and in step 2, we should swap it with the first unsorted element. At step 3, we should move the boundary between sorted and unsorted elements. Complexity analysis of selection sort. For time complexity, we have big O of n square in all cases for worst case and also for best case. We have big O of n square where n is the number of elements in the array. For space complexity, we only have big O of 1 because it doesn't require additional memory except for temporary variables. So let us discuss about sequential search. Sequential search is a simple searching algorithm that sequentially checks each element in a list or array until the target element is found or the end of the list is reached. Steps for sequential search. In step 1, we should start from the first element in the list. In step 2, we should compare the element with the target, and in step 3, we should repeat until the target is found or the end of the list is reached. Complexity analysis of sequential search. For time complexity, we have big O of n in the worst case and big O of 1 in the best case. In worst case, we have big O of n, where n is the number of elements in the list. If the target element is at the beginning, it takes big O of 1 time, making it the best case. For space complexity, we have big O of 1 because it doesn't require additional memory. So let's discuss about knife string matching algorithm. The knife string matching algorithm checks for occurrences of a pattern or substring within a text by comparing each character of the pattern with the corresponding characters in the text. Steps for the knife string matching algorithm. In step 1, we should traverse the text character by character. In text 2, for each character, check if the pattern matches starting from that position. In step 3, we should continue until the pattern is found or the end of the text is reached. Next, complexity of analysis of knife string matching algorithm. For time complexity, we have big O of n minus m plus 1 into m in the worst case, where n is the length of the text and m is the length of the pattern. The algorithm performs m character comparisons for each possible starting position in the text space complexity big O of 1 because it doesn't require additional memory. Comparison of time complexities. Selection sort. Selection sort, we have big O of n square. Sequential search. For sequential search, we have big O of n. Naive string matching algorithm. For naive string matching algorithm, we have big O of n minus m plus 1 into m. So let's discuss about advantages and disadvantages of brute force and when to use brute force. Advantages of brute force: simple and easy to implement, and it is applicable to small data sets. Disadvantages of brute force: inefficient for large data sets due to high time complexity, and not suitable for complex problems with many possible solutions. When to use brute force: small data sets with straightforward problems and as a baseline to compare against more optimized algorithms. At last, we will discuss about what we learned in this video. While these brute force algorithms are easy to implement, they may not be the most efficient for large data sets. These brute force algorithms are easy to implement, but they are not the most efficient for large datasets. For more substantial datasets, other algorithms with better time complexities, such as those based on divide and conquer or hashing techniques, may be preferred. Thank you for watching this video.